Okay, so welcome back, guys. Hopefully you watched that, and if you've watched it on Edpuzzle, then you'll have had my comments along there to just explain anything that didn't make immediate sense to you. So what I have in front of me here is a really cool website called GridWatch, and what it tells you is the current status of the UK's national grid. So we have here the demand for electricity. And that's shown by this needle here. So you can see at the moment when I'm recording this video, demand is low. If I recorded this during the daytime, when it was daytime in the UK, it would be over here. They did talk a little bit in the video, the previous video, about how the frequency changes. You don't need to know anything about how frequency changes, but what you can know is that if there's too little electricity, too little stuff being generated, the needle will drop over here. If there's too much being generated, then the needle will move that way. And this is where you can see, on these sections, you can see how much power is being generated by different things. Again, I'll give the link to the video on Google Classroom and in the comments. But when you hover over them, you'll get a little pop-up screen that will tell you information about them. So you can see that at the moment, the UK is not generating a huge amount of electricity due to coal, but there's quite a lot of nuclear being used. And this is gas, wind, pumped storage, hydroelectric, biomass, and you can hover over them. There are some other really cool little features of this website that help to explain some of the properties of different methods of generating electricity. So for instance, here you can see the demand over days. If you look at the weekly demand one, you can probably tell quite easily that it's night time whenever the demand dips. So that means that people are asleep, so not using their electrical devices. Also over the year, if you take a look here in the UK, it's winter around about November, December, and you can see that demand picks up a little bit in winter time. It's because it gets dark earlier, so people need more lighting, and some people heat their houses with electricity. The other thing that's quite interesting is you can then spot on these graphs so this is showing the nuclear and coal and gas, with also the wind. So what you can see is that the gas is very clearly following a pattern. It's being switched on and off. Now the reason for that is that we can turn gas on and off really quite easily. It doesn't take very long for a gas power station to switch on. Whereas if you look at the nuclear, can you see how the nuclear section down here is almost constant? That's because it takes nuclear power stations days to switch on and off. The other thing that I think is really interesting is if you look at the wind graph, you'll see that the wind obviously is unpredictable because we don't know when the wind will blow and when it won't. So it doesn't really follow any established pattern. That means that other power stations have to pick up for it when the wind isn't running. The pumped storage, that's something that you're going to be researching later. Again, what you will be able to see when you look at the pumped here is that when the demand is high and we're not making electricity from other sources, we use the pumped storage. So I'd really recommend you have a little play around with that. It's absolutely fascinating to see how over the course of 24 hours and then days and weeks, different combinations of power generation are used. Whoops. Now, what you need to know for your CIE IGCSE is the different types of energy resources that go into a national grid, the energy transfers that are in them, and some advantages and disadvantages of them. So that's what I want you to do next. So you're going to be going on to Seneca, and you're going to be using information that I've set you on Seneca in order to fill out this table. So I'm going to do the first one with you just to give you an idea of how it works. So for coal, oil and gas, the way it works is we burn a fossil fuel. Burning the fossil fuel creates heat or generates heat. That heat is used to make steam. So we boil some water. The steam turns a turbine. and the turbine turns a generator. Sorry about my terrible handwriting. The energy transferred then is chemical energy in the coal or the fuel to heat energy in the water that then gets boiled to kinetic energy in the steam and also in the turbine to electrical energy. So what are the advantages of this? Well, it's relatively cheap, although becoming much less cheap as time goes by. Actually now a lot of renewables are becoming cheaper than fossil fuels. But another advantage is that it's relatively simple. There are lots of fossil fuels left. Again, we are running out of fossil fuels, but for now it's abundant. Fossil. And that's kind of it. Also it can generate a lot of electricity. The main disadvantages, well, it creates greenhouse gases or releases greenhouse gases. I'm going to put GHGs, but you would put greenhouse gases. It's also non-renewable, so eventually we will run out. It also emits harmful gases like sulfur dioxide, things that cause acid rain, lung damage, that kind of thing. So it's been generally just bad news for the world. So what I want you to do now is fill out the rest of that table for me for the other types of power generation.